So today we are going to see about the CPU scheduling algorithms. So in that first we are going to see about the FCFS, first come first serve scheduling. Here we have four processes P1, P2, P3, P4 whose arrival time, burst time and priority is given. So we are going to consider only the arrival time and burst time for our case of FCFS. So all these scheduling algorithms will be illustrated through a Gantt chart. So I'll draw the Gantt chart first here. So the FCFS scheduling works based on the concept of the arrival time. So whichever or whoever the process which is going to come first, that has to be scheduled to the CPU first. So here when we consider the arrival time, only P3 arrives first. So at 0 millisecond we are going to schedule the process P3. And the P3 runs for us the entire time as it is going to be the scheduling first. So it is going to be the first schedule process. So we are going to run it for the complete time, and it is a non-preemptive scheduling. FCFS is always, and we are considering the case here as non-preemptive. So the total burst time is going to be 7 milliseconds. So I'll draw here. So I'll mark it as the burst time is 7. So for first 7 milliseconds the process P3 runs. Then we have to consider the next arrival time. So the next arrival time goes to, or the next process which is going to come first is after P3 is P4. So we will schedule P4 next. And we know the burst time of P4 is given as 3. So 7 plus 3, automatically here we will note it as 10, right? So that is the second process has been scheduled. The next arrival time, the quickest arrival time goes to process P2. So here next we will schedule process P2 here, and its burst time is 6. So already 10 milliseconds have been completed with the help of process P3 and P4. Now we are going to schedule P2, whose burst time is going to be 4. So again 10 plus 4, it is 14. Yeah. Next, the remaining process which is going to be the next one and the last one. So which is how much? So 0, 1, we have allocated P4. The next arrival time is P1, right? It is not P2. So it is P1. So P1, the burst time is 6. So 10 plus 6, it is going to be 16. So 16 milliseconds. Then comes the last process going to be the P2, whose arrival time is 3 and whose burst time is 4. So 16 plus 4, so totally 20 milliseconds, right? So in this 20 milliseconds, all the process has been scheduled completely, they have been executed. Next we need to calculate the arrival time for each and every process. Arrival time is given, so we have to calculate the waiting time, and after that we are going to calculate the average waiting time. So first we will calculate the waiting time for process P1. So P1, as we can able to see, the arrival time is 2 milliseconds, and when we have given the CPU for that particular process, that we can able to see in the Gantt chart. So in the Gantt chart, P1 is scheduled at 10 milliseconds only. So we need to calculate the difference, because the P1's arrival time is 2 and we have scheduled at 10. So automatically it is 10 minus 2, right? So that is 8 milliseconds. That is the waiting time for process P1, because the arrival time is 2 and we have scheduled process P1, or we have given the CPU for the particular process P1 only at 10 milliseconds. So the difference between these two is the actual waiting time for that particular process. Next is process P2. How we are going to calculate for P2? The same case. P2, the arrival time is 3 milliseconds and it has got the CPU at 16 milliseconds. We can confer from the Gantt chart. So what is the difference? Yes, we need to calculate like this: 16 minus the arrival time is 3. So that is 13 milliseconds. Next, for process P3, the same case. What is the arrival time for process P3? It is 0, and it has got the CPU at 0 millisecond itself. Yes, here, yes. So automatically 0 minus 0, that is 0 milliseconds. So it has not, the actual meaning is the particular process P3 has not waited for the CPU. Once it has arrived in the queue, it has been scheduled because the schedule is free. So we can able to allot it directly. Next, for process P4, the arrival time is 1 millisecond, and we have scheduled the process P4 at 7 milliseconds. So we need to calculate the difference here. So 7 minus arrival time for P4 is 1. So which is 7 minus 1, that is 6 milliseconds. So this is how we will be calculating the waiting time for each and every process, and all the units have to be mentioned in milliseconds, right? Next, we need to calculate the average waiting time. Average waiting time. So the average waiting time, sum of all these things divided by number of processes. So here it is 8 plus 13 plus 0 plus 6, right? So divide by the number of processes going to be 4. So it is about 27 total milliseconds. So 27 divided by 4. So 4. So that is the average waiting time for this particular process, right? That is for all these processes, the average waiting time will be 6.7 milliseconds. Next, what we need to calculate is the burst time. Burst time as given, we need to calculate the turnaround time. We call it as turnaround time, that is TAT. So turnaround time is the sum of waiting time plus burst time, right? So I'll do it like this: waiting time plus burst time. So we have already calculated the waiting time for each process. Say for example P1, the waiting time is 8 milliseconds. So 8 plus, what is the burst time for P1? It is 6. So that is equal to 14 milliseconds, right? Similarly, for process P2, it is the waiting time for process P2 is 13 plus the burst time for process P2 is 4. So 17 milliseconds. Next, for process P3, the waiting time is 0 and the burst time is 7. So it is equivalent to 7 milliseconds. Next, for process P4, the waiting time is 6 milliseconds. We have already calculated. So 6 plus, and the burst time is 3. So that is 9 milliseconds. So this is how we will be calculating the turnaround time for each and every process. Next, we need to calculate the average turnaround time, right? So the average turnaround time is again the sum of all the turnaround time divided by number of processes. So which is 14 plus 17 plus 7 plus 9 divide by 4. So which is 47. So 47 divided by 4. So which comes around 10. .1 milliseconds, right? So this is the average turnaround time for this particular scheduling algorithm. So now we have calculated the average waiting time and average turnaround time for the given process. So this is how we need to calculate the average waiting time and turnaround time, right? So this is FCFS scheduling, and the scheduling is based on the concept of first come first serve. Whichever or whoever the process is going to come first, they will be scheduled or they will be given the CPU. That is the meaning of scheduling, allotting the CPU to that particular process, right? That is what we call it as scheduling. So this is the easier scheduling algorithm, and we have seen the concept of non-preemptive first come first serve, right?